Everyone, welcome back to my channel. So today we are gonna discuss about the most important concepts of AIML, that is problems in AIML. So I have divided this video into two parts, that is part 1 and part 2. In part 1 I'm going to discuss about module 1, 2, 3 problems, and in part 2 I'm going to discuss about problems in 4, 5 module. So let's begin with the video. Yeah, so starting with the module 1. So here I have considered various problems, that is here you have tic-tac-toe and water jug problem and A star, A star, and crypto arithmetic problem. So this is the only few problems which is there in the module 1. So basically here in this module 1 you have not a mathematical problem kind of thing, but yet you have some problems. So let's begin with the video. So here I'm gonna start with the tic-tac-toe. So it's not a problem, but it's a type of a question where it is very important. So let's begin. So everybody know the tic-tac-toe problem, tic-tac-toe game. So here what will be there? So two opponent, two gamers will be there. So 0 and the next, if any consecutive x or zeros come together like this, then he or she will be the winner, right? So the question arises like this: discuss the tic-tac-toe problem in detail and explain how it can be solved using AI technique. Yeah, so let's begin. So as I said, so this is a tic-tac-toe problem. Here you have 9 cells, that 1 2 3 4 5 6 7 8 9 9 cells, and we can include the values zeros or x alternatively, correct? So one time the user x can enter x and another player can enter 0. So alternatively these two members should play. So that is how it goes. And so how it will work in AIML, so how can it be implemented in AIML, that is discussed here. So here in this tic-tac-toe problem we have 3 approaches: first approach, second approach, and then final approach. All of them are very simple, and slight difference is there. So how it will work is, so whenever there is an alternative state, so whenever the user enters one state, for example user x entered x, then it will try to eliminate the losing possibilities and try to capture or try to move in a direction of winning possibilities. So that is how it works. So going with the first approach, okay, so here since each blank or each cell has a 3 values, that is blank, x, and then 0, okay. So I hope this is clear. So whenever you are playing, so now it's blank, this is one state. So now user has entered x, so this is one state. The user can also enter 0, so this is one state. So likewise each cell or each column or each block has 3 values. So this has got 3 values, so this has got 3 values. The user can enter 3 values in each block, okay. So then the possible moves can be 3 power 9 states. So the valid moves can be 3 power 9 states are possible, okay. Yeah. So now first approach, here what we will do here in this first approach, so the game consists of 9 element vector called as board vector. Here we will consider 2 vector, that is board vector, and another one vector, that is move table vector, okay. So it represents in the form of number, it represents the number 1 to 9 in a rows. So 1 2 3 4 5 6 7 8 9, so that is how it is represented, and it contains a valid 3 moves, that is 0 for blank, and x for 1, and 2 for o, or that is 0 or o, okay. So this is o. So each value has some value. Each that is blank has got some number, x got some number, o got some number. So each value will be assigned by some number, so it will be helpful to compute. So in move table it contains 3 power 9 elements, so it is needed for where each element is there in the 9 element vector. So in order to keep track where it is, so we will do this, we will use this move table vector. I hope this is clear. And now yeah. Yeah, so begin with this board vector. So here data structures, that is we use the two main variable, that is board and then move table. In board we have a 9 element vector representing the board, where the element of vector corresponds to the board position as follows. That is 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the board position, so that is represented in the board vector. And next we have move table. Here move table consists of each element of which a 9 element vector. So the content of this vector chosen specifically to allow algorithm to work. So here it is needed to in which the each element of 9 element vector chosen specifically to allow the algorithm to work. So that is how so as the name says, it is used to represent where the current position of the element is there. So that is it. And moving on to the algorithm. So algorithm I forgot to mention it here, so I will just explain theoretically. So yeah, so first what we will do is, in the step 1, first what we will do is, so we will look into the board vector. So we will so here we have a ternary number. So we have the board vector as a ternary number. In the board vector we have a ternary number because each cell has a 3 values, that is 0, 1, 2. So we will look this as a ternary number and we will convert that to the decimal number. Okay, so this decimal number will be converted. So use the number computed in this step 1 as an index into the move table. So when we get the value in the decimal number, we use this into the move table as an index to access the vector stored there. So in order to access the vector stored in this block, first we will convert that to the decimal number and we will check that in the move table. So when you get the vector stored there, so the vector selected in the step 2 represents the way the board will look after the move that should be made. So set the board equal to the vector. So the value which we got in the vector or the vector stored here in that position will represent that how the board will look after we move to that position. Okay, so now what we will do is we will set the board equal to this vector. Okay, so first, what is in a simple terms, what I'm trying to explain you is, first I will consider the position. Okay, so first I will consider the vector or a board vector in this board vector variable. So from that I will extract one decimal number. From that, if it is 0 or if it is 1, if it is 2, I will extract that decimal number. With the help of move table vector, I will extract the vector, I will extract or access the vector stored there. I will give this as an index and I will move there and I will extract the vector stored there. So I will assign this board vector to the move table vector, since this is how it will look once you move it. Okay, so that is the algorithm. So you can write it in your own words. So yeah, the difference in the second approach is that here we will consider 3, 2, 3, 5 as for blank x and 0. That is it. So variable turns indicates a first move, and last move we have 1 to 9 moves in the variable turn, and makes we have a few variables. That is for example how it works in second approaches. For example here as you can see this I hope you can see this game. So currently let's take this as a game. This is a game running. Now it's a turn of an x. Now here if x move to this direction, then there is a high chance of getting or high chance of winning, correct? So the value returned by this pause win or the position win will be 7. 1, 2, 3, 4, 5, 6, 7. Okay, now it's clear. So what I am trying to tell you is, so first you have 2, 3, 5, 4, 0 blank x and 0, and the variable turn indicates the moves from 1 to 9. So we have possibly 9 moves, that's it. So in a pause win, what it will return is, so the position or the position where there is a high chance of winning. So it will return 0 if P cannot win. So if it returns 7, if we move to the position 7, there is a high chance of winning. So that is what it is explained in the second approach. And the third approach, final approach, is a list of position that could result from the next move. For example, if I move here, to this position. So the least of position that could result from the next move, and algorithm has all the possibilities or all the chances of winning moves will be given there. List of winning moves will be decided, and it will look ahead and makes the decision on the next move. Consider all the moves and replies. So considering all the moves, it will select which is the best move out of this, and it will return. So that is it about the tic-tac-toe problem. This is a very simple and then theory question. You can just learn it easily. And moving on to the next question, next very important question, that is water jug problem. Here this is repeated in the previous year question paper also. Let's see what is this problem is all about. Yeah, here is the problem. What is the problem? You are given with the two jugs, 4 liter and then 3 liter. 4 and then 3 liter jug. Neither has a measuring marks on it. Neither of this two jugs has a markings. That is, there is no measurement mark on these two jugs. So there is a pump can be used to fill the jugs in the water. How can you get exactly 2 liters of water into this 4 liter of jug? With the help of this 3 liter jug, or with the help of any any water or the any tricks, you need to fill this 4 liter jug by only 2 liter of water. So I will explain the problem again. I hope here you can have it. Yeah. So the given statement is, here you have 4 liter jug and 3 liter jug, and one tap is there. Okay. So with now the problem is, you need to fill this 4 liter jug by only 2 liter of water. You don't have measurement scale, you don't have any markings here. Just you need to fill this 4 liter jug by 2 liter of jug. How can you do that? So I will explain the problem. So later I will move. Later I will go with the steps. So step 1. What can you do? So first you can fill. So first what you can do, first you will just, this is 4 liter jug and this is 3 liter jug. What can you do? So first you have to fill this 4 liter jug by, you have to fill this 3 liter jug by 3 liter jug. Okay. Pour this 3 liter jug to 4 liter. Now the state will be, this 4 liter contains 3 liter water, and now this is empty. Empty, correct. So now again fill this 3 liter of jug. This contains 3 liter. Again fill this 3 liter of jug by full, and now what's the state? This is also contain 3 liter of jug, 3 liter of water. This also contains 3 liter. Now what you can do, again pour this 3 liter into this 4 liter jug. Here you have only one empty space. So now just pour this all the 3 liter water to this. How much liter or how much amount of water it can accommodate? It can accommodate only 1 liter, correct? So there is only 1 liter of space here in this water jug. So how much you can fill? You can fill only 1 liter. So when you pour it, 1 liter will go here and the remaining will be 2 liter. I hope this is clear. Now I will pour this 4 liter out. I have here in this 3 liter, I have only 2 liter of water. What I will do, I will use this to fill this 4 liter by 2 liter of water. Okay, I will explain it once again. So first fill this 3 liter of jug. So I will change the color, hope that will be helpful. First fill this 3 liter of jug by 3 liter. Okay. Pour this 3 liter of water into this 4 liter jug. Now you have 3 liter here in this 4 liter, and this is empty. Now again fill this 3 liter by 3 liter. Now you have 3 liter on both the sides. Okay. So here also you have 3 liter. Here also you have 3 liter. Now you have only 1 liter of space in this 4 liter jug. Now pour this 3 liter water into this 4 liter jug. How much it can accommodate? It can accommodate only 1 liter, and the remaining in this 3 liter will be 2 liter. When you fill this, so remaining it would be 2 liters. Now you got exact 2 liter of measurement without any measuring scale. So now pour this all the water in this 4 liter jug. Now it will be 0. Here it contains 2. Now pour this 2 liter water into this jug. Now what it will be? 2, and this will be 0, or it can be anything. I hope this is clear now. First you need to fill 4 liter and 3 liter. So here first you need to fill this 3 liter full and pour to this water, and now this contains 3 liter and this is empty. And now again fill this 3 liter, that is now you have 3 and 3. It can accommodate 1 more liter extra. Now pour the water present here to this jug. Pour the water to this jug. Now it can accommodate 4 liter, and the remaining here will be 2 liter. So that is it. So going through the solution properly. So here you have states x and y, that is x is nothing but a 4 liter jug, y is nothing but a 3 liter jug. So what are the possible states or the possible values it can have? It can have either 0 liter, 1 liter, 2 liter, 3 liter, and even it can have 4 liter also. When we consider the 3 liter jug, it can have 0 liter, 1 liter, 2 liter, and up to 3 liter it can hold. Correct? So now, and the next starting state would be 0 and 0, and the goal state would be 2, n. Why n? 2 means the 4 liter water, 4 liter of jug must be filled with the 2 liter. That is the case, and the 3 liter may contain 0, 1, or 2. It doesn't matter. So it can contain any values. So that is why it is mentioned n. Now next, coming to this production rule. So this is very important. If you don't know this production rules, just don't try to attempt this question at all. If you write this production rule, then only you will get the full marks. So production rule, so why do we need this? I explained the steps, correct? So first you need to fill this and fill this, etc. So the set of rules is explained here. See, the first rule is x comma y if x is less than 4. So what we are trying to do is we are filling the 4 gallon of jug. So when x comma y, so this is the current state. So once you do this state, what will be the result? So this is how it is explained. So this is the current state and this is the result, and this is the explanation regarding that. So what we are trying to do. So whenever we have 12 production rules, you need to learn all of them thoroughly. Okay. Now, so first, a production rule, x comma y if x is less than 4. So if x is less than 4, what we are trying to do is if that 4 liter jug is less than 4 liter, then what we are trying to do is we are fill the 4 gallon of jug. So we are trying to fill it. So the result will be 4 comma y. If y is less than 3, then fill it is with the x comma 3, that is we are filling the 3 liter of jug. And now, if x is greater than 0, that means x has got some value. So pour some water out of the jug. That some water is represented by D. So here what we are trying to do is we are subtracting or we are reducing some water from this 4 liter of jug. So what we can write, x minus that some water. That is the result, correct? So x minus some water comma y. So if y is greater than 0, so then we need to pour some water out of this 3 gallon of jug. Then it will be x comma y minus d. So if x is greater than 0, so empty this 4 liter of jug. That means we need to pour the water onto the ground. If y is greater than 0, then we have to empty the 3 liter of jug water. So that will be x comma 0. Now, so what we are doing here is, so this up to here we had a very basic rules. Now here comes the very important rules. So the condition is if x comma y, if x plus y is greater than or equal to 4 and y is greater than 0. So what they are trying to explain is if this has some 3 water and if this has some 3 water and this has got some 3 liter of water. So if I add it both of them together, so what I get 5. 5 is greater than or equal to 4, correct? So the condition is satisfied. Once you get this condition, you can fill this 2 liter of 4 liter jug by remaining water and you can make it 4, correct? So that is what they are explaining. If x plus y is greater than or equal to 4, then the result will be 4, correct? So I just filled this 4. Previously it had 3, for example. So this has got 2 liter. Okay, 3 liter. So in 4 liter you had 3 liter and in 3 liter you had full. So this is the case. Okay, now what you're trying to do is so I will add. So 3 plus 3 is 6. So this is x plus y is greater than or equal to 4 and y is also greater than 0. So the condition is satisfied. What I will do, I will fill this water up until the 4 liter jug is full. Now the x value is 4. So now I need to subtract the remaining water. I need to calculate. How can I calculate the remaining water? So how can I calculate the remaining water is y, that is 3 liter of jug, y minus, so the x, that is whole this value, x minus, so y minus 4 minus x, because so y from y is the previous y value, so 4 is the total, so here we need to calculate how much amount this accommodated. So that is how we need to calculate. How can we calculate? So the 4, this is the full value we got, 4 minus the previous value what it had. So with that value we can get the amount, the empty space it had in this earlier. So that is the equation of y minus 4 into x. I will explain it once again. Say for example, this has some value. This is 3 liter and this has 3 liter of water. Okay. Now you need to find how much empty space is there. So when you find this empty space, we will get to know that how much liter of water it can accommodate. How can you minus, that is 4 minus this 3, then it will be 1, correct? So what I am trying to do is, so 4 minus x will give the remaining empty space. So I'm gonna fill this remaining empty space with this value, with the 3 liter of jug. So what is remaining in this 3 liter jug? Y minus this empty space value. So y minus this empty space. So that is how we got this equation. I hope this is clear. And moving on to the next condition, that is x plus y is greater than or equal to 3. Then we have to do the same thing, that is x minus 3 minus y comma 3. And now if x plus y is less than or equal to 4, then what we have to do is we have to pour all the water from 3 liter jug into 4 liter. If x plus y is less than 4, what we have to do? We have to pour all the water from 3 liter to 4 liter. So then this will be 0, since we are pouring all the 3 liter of water. So see, it will be 0 and the x value will be x plus y. So if x plus y is less than or equal to 3, then we have to pour all the values from 4 liter to 3 liter. Then the equation will be 0 comma x plus y. So now, when you get the value 0 comma 2, what we have to do? We have to pour the 2 liter into the 4 liter, because that's the that's the state, correct? So the final state will be 2 comma 0. So whenever you get a 2 comma y, so what we are trying to do is we are emptying the value to 4 gallon of 2 gallon onto the ground. So this is a just overall production what we can do. So yeah, coming to the problem. Yes, so here we have one solution. So we are using few production rules from the above. So we are trying to solve it. So first we will consider 0 comma 0. This is the initial state. And now we will consider 0 comma 3 with the help of production number 9. So what we are trying to do is we are filling this 3 gallon of jug. And now we are pouring this 3 gallon of water to this 4 gallon with the help of production 2. So what it says is, if the y value is if it is greater than 0 and x value is 0, then what we have to do? We have to pour all the water from 3 liter jug to the 4 liter. So with the help of again production 2, what we are doing? We are trying to fill the 3 gallon of water to this 3 liter jug. And with the help of production number 7, what it says is, whenever the value of this both x plus y, that is 3 plus 3 is greater than or equal to 4, what we have to do, we have to pour this water into the remaining space of this 4-liter jug, and we have to calculate the sum. So that is, if this has got only one empty space, we have to add 1 to here and we have to subtract 1 liter from y. So that is how we got 3 plus 1 is 4 and 3 minus 1 is 2. That is how we got. So whenever we have this value again with the help of production number 5 or 12, what we can do, we can empty this and we can leave as it is. Now we got 0, 2 with the help of this production number 5 or 12. What we can do, we can pour this 2 to this 4 liter of jug. With the help of 9, we got 2, 0 as our final output. So that is it. So I will explain it again. First I will take initial state at 0, 0. So with the help of production number 2, we will apply, we will fill this 3 liter jug, that is 0, 3. And with the help of production number rule number 9, we can pour this 3 liter of jug into this 4 liter and we can empty this. So because since x plus y value is less than or equal to 4, so we need to just pour all the water from 3 liter jug to this 4 liter. So the resultant will be 3, 0. And with the help of production rule 2, again we need to fill this 4 liter jug again. With the help of production rule number 7, that is since x plus y value is greater than or equal to 4, we need to pour the remaining water or the remaining space, we need to fill this remaining space. So the remaining space is 1. So we need to, we are filling 1 liter. So from this 2 liter, so we have to subtract, add 1 to this 4 liter and subtract 1 from this. So we got 4 and 2. With the help of production number 5, what we are trying to do is we are pouring this water out of this 4 liter of jug. So that will be 0, 2. With the help of production number 9 or 11, what we are trying to do is we are assigning this 2 value to this 4 liter of jug. So that will be 0, 2, 0. So that is the final state. Starting with the A star algorithm, here you need to just find the starting point and the minimum path between S and then G. What we need to consider here, we need to consider which is the minimum path. So which is the minimum path from S and G. The answer which I have written in the notes is wrong, so please make sure that you will correct it. So from starting from S to G, we need to find the minimum path. So I'm doing this video since you have to write the algorithm for this. So I thought that the problem, explaining the problem would be very helpful for you. So now starting with the A star algorithm, here from S to G, you need to move from, you need to find them which is the minimum cost. So here consider we have formula S of n is G of n plus H of n. For example, you are moving from A and from A you are moving from E. So what you need to do is we need to add the cost of this one, that is G of n and G of n, and we need to add the heuristic of this E. So if you are moving from S to E, what we need to do is we need to take the cost of this one and the cost of the final node, that is heuristic of that A node. So by calculating we can guess that, so that is from out of this 10 plus 16, 13 plus 5, 18 and 10 plus 9, 19. So this has got the minimum value. So now from here you have only one path, we need to choose this at any cost. So from here also you have got only one path, you need to choose this at any cost, and from here also you have got only one path, you need to choose it at any cost. For example, if we had a chance where we got this S and B, so we have to choose which is minimum. So then it will be 5 plus 6 will be 11, 11 plus 4 will be 15. So and 5 plus 7 will be 12, 12 plus 2 will be 14. So which is minimum? So this one, correct? So we have to choose this one. We have got only one path and one path. We have to choose that node. So that is how A star is calculated. And moving on to the next path, the next problem, that is AO star. Here you have to choose this or that. That is and or graph will be there. And is represented by arc like this. So here as you can see, this is an and arc. If there is no any arc, then it indicates that this is an or. And is nothing but yes. So here you need to take, for example, if any AND arc is there, you need to take both the path also. Like you need to consider these both or this one. So that is how it is. This both or this one. And is nothing but both. Okay. So for example, I have let's calculate the cost, which is the minimum cost. Now as I said, since there is an AND arc, we need to consider this both B and C. The value for this will be 4 plus 3, 7, 7 plus 2, it will be 9, 10 plus 1 will be 11. So which is minimum? This one. So we have to consider this both B and C. Okay, now after considering B and C, from C you have I, you have got only one node, then you have to choose it at any cost. So now we have B and E or F. There is no AND or between E and F. Now we can choose either E or either F. Which has got the minimum cost, then we have to find that. So for example, if it is having a 3, then 3 plus 1 will be 4. So 2 plus 1 will be 3, which is the minimum. So this is the minimum, then we have to choose this one, F. Okay, and we have to remove this E. So the path will be A, B, F, C, J. Okay, I hope this is clear. And moving on to the next concept, that is constraint satisfaction. This is not that much important, or this is very this is very kind of take a considerable amount of time in order to solve this, and it will take a lot of patience to solve it. So yeah, starting with this constraint satisfaction, what we have to do is we have to solve send plus more, which will satisfy this condition money. So what we need to do is we need to assign each unique values from 0 to 9 to all these letters, and no two letters should have same value. So I repeat, these are the rules. That is, you need to assign unique values from 0 to 9 for each letter, and no letter should contain the same value. So that is how it is generated. And carry, it can have a carry can take either 0 or 1, that much only, so it can repeat. Okay, so now let's start. So here let's start from the left side. Here you have some value, that is you have x plus y, which is giving some value, two values it's giving. So what is this? So this is nothing but a carry. So I will explain you. For example, let's take 8 and you have another one value 9. So this is exact similar to this condition. So now 8 plus 7 will be 7, and it will generate on carry. I will write it here 17. So this is nothing but S, this is nothing but M, and this is nothing but M, and this is nothing but O. Okay, so now, so what I'm trying to tell you is, by adding two values, it is generating some value, that carry is being assigned to this value, correct? So I can easily say that this is getting carry received by these two numbers. So now I can say that this is carry is 1. How can I say carry is 1? So maximum value, what can I assign is 9 plus 8. 9 plus 8 will be 17, so 1 is carry, correct? So 1 is the maximum carry which I can receive. So I will assign M with the 1. Okay, now S plus M will be M. So I am getting the carry, so I will assign with the 1. So M, wherever M is there, assign that with the 1. Okay, so now we got the M value. Now we have to find the S and then O value. So how can you find this S and then O value? So the solution goes like this. What value should I add to 1 so that it will generate 2-digit number? So what can I add? So you have got only from 0 to 9 values numbers. We can check only 0 to 9. So out of which 1 is already ruled out. We have to check which value will generate 2-digit number. 2-digit number. Why 2-digit number means here the 1 will be sent as a carry, and it should generate another one value. So 2 numbers. What can it be generate? How can it be generated? Let's take from 2. 2 plus 1, 3. There is no carry generated. So next 3 plus 1, 4 is generated, but there is no carry generated. And now 5 plus 1, 6, there is no carry generated. And 6 plus 1, 7, there is no carry generated. And similarly, let's go to 9 plus 1, 0, 10, carry is being generated. Now M has got 1 value, and O has got some 0 value, and S has got some 9 value. So now 1, 2, 9 is ruled out. And now assign wherever S is there, assign with the 9, and wherever 0 is there, assign that with the O. Wherever O is there, assign that with the 0. Now we have to take the next equation, that is E plus O is equal to N. So now how can we, what is the value of O? 0, correct? So the equation will be E plus 0, nothing but N. So then we can write it as E is equal to N. But this should not happen, because no two values should contain the same value. No value should have same value, correct? So now there must be some number added to this E, so that it will not be equal to N. Okay, so that is nothing but it should have some carry. So carry plus E will be equal to some number. So we have to check which number is suitable for this one. So let's take 2. So we have to solve the equation of these 3 again, and we have to check for 3, and we have to check for 4, and we have to check for 5. So 5 is more suitable when compared to any other values. So I will take this E as 5. Now if I take E as 5, so carry must be generated. 5 plus 1 will be 6. N value will be 6. Now 5 and 6 is also ruled out. So N value is 6, and now here what I have to do is E is 5. Okay. And now what is the value of R? What should be the value of R? 6 minus 5 is equal to R, correct? If 6 plus R is equal to 5, then 6 minus 5 is equal to R, correct? So R cannot be equal to 1. So what does it mean? It should generate on carry. So then R value will be equal to 8. Okay, so R value will be equal to some 8. So because it's generating on carry, it should have 2-digit number, and so 6 plus 8 will be 14. 14 plus 1 will be 15. So 5 plus 1 carry is generated. That condition is also satisfied. Now here you have 5, and now we need to choose two numbers such that it will generate carry. So the 2-digit number that will generate a carry is left out is 7 plus 5, that is 12. 12 1 carry. And now we have got 6 plus 8 14. 14 plus 15, 5 1 carry. And now 5 plus 1 6. 6 plus 0 is 6, that is also satisfied. And now 9 plus 1 10. 0 1, that's 1. This condition is also satisfied. So that is that much. So I will just since the video length is very going very lengthy, so I will just cut it off now here itself. So I will do another one video for module 2, another one video for module 3, and likewise I will do. So I hope this video is helpful for you, and learn it and do well in your exams. Thank you.